aircraft play an essential role in how we study and understand Earth's surface, climate, and atmosphere. Now, a new commercial unmanned aircraft system, UAS, aims to bring about a powerful way to observe our planet for days or weeks on end. With the help of NASA's Ames Research Center in California's Silicon Valley, Swift Engineering of San Clemente, California, completed a 2-hour flight test of their Swift High Altitude Long Endurance, HALE, UAS. The applications of the technology, for science, agriculture, and disaster response, could have a real impact on our everyday lives. Swift's 72-foot solar-powered HALE weighs less than 180 pounds, flies 10 to 15-pound payloads at a time and is designed to operate at an altitude of 70,000 feet for 30 days or more. Despite its wide wingspan, Swift's HALE is similar in size to a small general aviation (GA) aircraft, but at a fraction of a GA's weight. Compared to the NASA ER-2, which also operates at a maximum altitude of 70,000 feet and can carry a 2,600-pound payload for missions over 10 hours, the Swift HALE UAS is capable of flying lightweight payloads for days and weeks on end. Current NASA science aircraft can meet most, but not all, observing system requirements. HALE aircraft can provide unique data to complement and improve NASA measurements from orbit, said Matt Flat-Eland, a researcher at Ames working with Swift on the aircraft. Developing the HALE with Swift has opened up more possibilities than we initially imagined. The successful flight test is an important first step towards realizing a new capability to support NASA's science. In 2016, Ames, whose expertise in unmanned systems included aircraft development, airspace integration, and airborne science, partnered with Swift through the agency's Small Business Innovation Research/Small Business Technology Transfer (SBIR/STTR) program on a proof of concept for a solar-powered UAS. With its expertise in UAS and solar-powered technology, Swift received NASA SBIR awards to develop a unique solution that could sustain flight for a month or more. Before the aircraft was ready for its first flight test, the Swift team, in consultation with NASA researchers, had to research solar panel and battery technologies to develop a system that could provide enough power to stay aloft at night until it can charge its batteries the next day. The cells also need to retain high power capacity after several recharging cycles. Other design considerations included the need to withstand the harsh temperatures, radiation, and other conditions of the upper atmosphere, and past NASA Global Hawk flights helped to characterize the operational environment. During the first of a series of flight tests completed successfully at Spaceport America in New Mexico on July 7, the Swift crew conducted operations at low altitude, passing all systems checks and validating aerodynamic, control, and power system models. By sustaining flight for 2 hours, the calculations from the flight test provided confidence in the UAS's ability to maintain missions longer than 30 days. This flight is the first of many that will collect data to further validate the vehicle's design requirements. This program signifies an important partnership with NASA's science and aeronautics. Together, we designed a UAS that fulfills the agency's use cases and aligns with the Federal Aviation Administration's vision of how HALE vehicles should be deployed and maintained for extended periods, said Andrew Street, Vice President of Technology at Swift Engineering. Sustained, long-duration flights are only just becoming a reality with a new generation of batteries and power efficiencies.